Okay, so we are in section 6 for chapter 1, section 6 for math 8. Let me scooch down. Can we actually see? Yeah, we can see that title up top there. I just scooted it down a little bit, so go ahead and scoot it back down. So we know we're in section 6. And we are going to start on scientific notation. So this should be a bit of review. We should have seen this before, but we're going to go ahead and review all the pieces, all the labels for scientific notation. So first, off to the side here, we have the main concepts and questions. So the first thing, it just tells us scientific notation. So this is the main concept. And then what we're going to do is students use scientific notation to write very large and very small numbers. So that's exactly what scientific notation is for. It's meant to help us write very large or very small numbers. Instead of having to write out all of those digits, we can reduce it down to using powers of 10. So let's go ahead and take a look at the labels here. So this number in front is what we call the coefficient. And that should not sound brand new to you. You should have heard that word before. Coefficient is just the number in front of the variable usually, but in this case it's the number in front of the power of 10. Then we have the multiplication sign. Like that. All right. And now over here, this pink arrow here, and I know on your paper it's probably not pink, but this arrow here is pointing at the exponent. And then this whole thing, this circle, it's circling the entire thing. So this is, we call this the power of 10. So this is a power, and specifically it's a power of 10. And then this arrow here at the bottom is pointing at just the 10. I know they should have gone up probably a little farther in here so that you knew that it was the 10 and not the circle they were pointing at. So this is the base of 10. All right, so these are our labels here. And one piece I want to add to this label is the coefficient. If we think of it like a variable, or we can just say it needs to be less than 1, less than or equal to 1, sorry. So it has to be less than or equal to 1. And it has to be, I put that on there wrong, sorry. I'm going to just erase. Oh, no, I'm not. That'll erase way too much. So I'm just going to undo. Sorry, I was saying that wrong. It needs to be more than or equal to 1. So it has to be more than or equal to 1. Right here, that's the number I'm talking about. So 2 is more than 1, so we're good. But it has to be less than or not equal to, just less than 10. So basically this cannot be more than 1 digit is what that's saying. It can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be less than 1, so this can't be a 0. And it can't be more than 9, so it can't be 10. So it has to be something between 1 and 9. So that's a big rule there. We always have 1 digit in front of the decimal place here for the coefficient. All right, so if we look at this table down below, this is just showing us there's a standard version, there's the kind of deviations of 1, deviations of 10, scientific notation. So if we're looking at this, we have 3 times, or just look at the standard version first. Here we have 0.003. And if we take the 3 out, so that's what they're doing here, 3, we'd have 0.001 multiplied by that 3. So that's all this is showing you in this column. This is a power of 10, but it's negative because it's a small number. So remember, small numbers have a negative exponent, large numbers have a positive exponent. And really, it doesn't have to be very large or very small. That's not what that means. By large or small, what we mean is less than 1, greater than 1. That's what large and small mean. All right, so it can be much, much less than 1 or much, much greater than 1, but it could also just be barely bigger or barely small. As long as it just has to be on one side or the other. So in this case, we have, it's definitely smaller than 1, so that means that it's going to be a negative exponent. So a negative exponent, all that tells you is that it's actually a fraction. And we practice this. If that doesn't sound familiar, go back and watch the video about zero and negative exponents so that you remember how that works. So they're showing to get this number, we'd have 1/10 times 1/10 times 1/10. Well, there's 1, 2, 3 tens. So we can write that as 3 times 10 to the negative third. So they're just showing us how we can go from the standard number to the scientific notation, all right? And one thing that you can do is you can say, well, how many digits are here? If I want to move this decimal, because remember, it needs to have a number in front of it that's from 1 to 9. So I need to move this and go 1, 2, 3. It needs to be behind that 3. So that means I had to move it 3 times. Look at that, 3. So they do match. But because I'm going from a decimal to a whole number, so I went from 0.003 to just 3, it has to be negative. That tells me it was a decimal. It's a small number. All right? So we have to pay attention to whether or not we're going from a small number or we're coming from a large number. So if you're coming from a large number, like let's go to the other end here, now we'd have to move this 1, 2, 3, 4, 5, 6 times. We'd stop right there behind the 3 again. But I had to move it 6 times. If I go to the bottom here, I can see that there's an exponent of 6, but it's a positive 6 because that's telling me it's a large number or it's a number larger than 1. All right. Whoa, forgot I'm doing the wrong tool here. Let's move down, and we are going to take a look at the next piece. So it says, what is the relationship between powers of 10 and how many places a digit is moved left or right when converting numbers into scientific notation? So that's exactly what we were just talking about just a second ago there. So the number of digits that you move either left or right tells you what the exponent on the power of 10 is going to be. So it's exactly what it tells you. And if you're moving it, it's a positive exponent if we move the decimal to the right. It's a negative exponent if we move the decimal to the left. So if we're moving this direction, that's going to be negative. If we're moving this direction, it's going to be positive. And this is just for the exponent, just for this, the little lifted number there. Okay? And the number of times we move that tells us what that exponent will be. All right. So I'm going to move down here. And you should definitely, I know I didn't write everything I just said, but we should definitely write out a definition there. Let's see. Sorry, my pen tool is still being silly here. So write each number in standard form. So they give it to us in scientific notation, and we have to write it in standard form. So we have to take it out of scientific notation. So we're going to kind of do the backwards concept of what I was just showing you. So now I have 3.16, and I have an exponent of 3. That means I moved the decimal 3 times to get to this notation here. So I'm going to move the decimal 3 times again. I'm going to move it in the opposite direction to make this number bigger. Remember, positive means bigger. Negative would tell me to go smaller. If you have a blank here, that means fill it in with a 0. So this would be 3,160 in standard form. All right, so this one we have 1.1, and I have a negative 4. That's telling me it's a small number. So in order to take it out of this notation, I want to go this direction. 1, 2, 3, 4. And that'll be my new decimal place. Every spot that doesn't have something, I need to put a 0 in there. And don't forget, when we have a decimal, you need to put a 0 on the front. That is the proper way to write it. So we have 0.12311. We don't have a decimal here anymore. Remember, we were moving that. So there's no decimal in between the ones anymore. All right. And oh, dang it. Yep, this is still section 6. So we're just going to the top here. All right, so we're still in scientific notation. We're still talking about using scientific notation to write very large or very small numbers. Again, large just means larger than 1. Small just means smaller than 1. That's all it means. Doesn't have to be very large or very small, but that's usually what we use it for. If it's close to 1, we're probably not going to use scientific notation because it's inconvenient to look at. It's more convenient to look at for these large numbers, especially if we're starting to look at like exponents of -35 or -23. Okay, that's a lot of digits to have to look at if we had this written out in standard form. All right, so blank blank is when a number is written as a product of a factor and an integer power of 10. So this is kind of the math definition, definitely, of scientific notation. So it's a number is written as the product of a factor. So that means a number. And an integer power of 10, meaning that we have a power of 10 with an exponent on it. The factor must be greater than or equal to 1 and less than 10. So we've already kind of covered that. All right, down here we're just going to circle the numbers that are written in correct scientific notation. They all look legitimate, but remember that number in the front, there should be 1 digit and then a decimal place. It is going to be between 1 and 9. So this one follows the rules. There's 57. Technically, the decimal place is there. We don't even see it because it's just, we don't normally put the decimal place unless there's more numbers. But this would need to be 5.7 in order to follow the rules. So that doesn't work. We'd have to move that decimal. 3, remember the decimal place is just right there, even though we don't see it. This works. That's between 1 and 9. 78. That's definitely bigger than 9. We would have to fix this and move the decimal again. So that does not work. 0, that's not between 1 and 9. Remember, it has to be greater than 1 or less than 10. Sorry, greater than or equal to 1. So this does not work. It's not written correctly. This is 9, so that's perfectly fine because it's 9.89, so this one is written correctly. So the main practice here is we're just looking for the numbers that have 1 digit between 1 and 9 for that first number. All right. Oh, I keep forgetting that changed. Okay. So 14, we want to do these problems. So what they want us to do is write these in scientific notation. I think the directions were slightly forgotten there as far as what to do, but what they want us to do is put these in scientific notation. So what we need to do is figure out how many times we're going to move that decimal, because we're going to have a number times 10 to a variable. So we're going to have a number in front here. We're going to have a variable. We need to know these two numbers. So I'm going to take this decimal. Remember, it's on the end here. Even if I don't see it, it's all the way in the end. There is no other decimal. 1, 2, 3, 4, 5, 6, 7. I want to stop right there because I want it to be at least 1 there. So I'm going to move it 7 times. This was a large number, so it's going to be a positive 7. And then I'm going to just write this out, 1.414. I don't need to write the zeros anymore. I go to the last significant number, which is not the zeros. Now, if there was a number, say on the end here, by chance there was like a 1 or a 2 or 3 or something on the end there, instead of it being a 0, now they're all significant again. Okay, so be careful when I say significant, it means there's no more other numbers. It's only zeros. Then I can drop them off. Okay. All right, this next one, we're going to have the same thing. We're going to have a number times 10, and we need the exponent. So we're going to take this decimal and we're going to go 1, 2, 3, and I'm going to stop right there because I don't want to keep going. That would be bigger than 9, right? I want to stop, so I only want to go to the first digit. If I'm going from a small number, then I go to that very first number. If I'm going from a large number, I have to go all the way to the beginning. So it just depends on what I'm doing. So that was 1, 2, 3. So it's 3, but remember, this is a small number. So I need to indicate that it's a small number with a negative sign. Doesn't mean it's a negative number. It means it's a small number. So 8.76, because I moved that decimal right there. All right, now again, we have another small number, so I'm going to end up with another, that's a big 10. That's a little ugly looking. Let me fix that. 10. This is going to be a negative exponent. I can already tell that because it's a small number. So I'm going to go 1 I'm only moving at one time. It's going to be negative 1, 1.14. All right. So now the areas of the world's ocean are listed in the table. Order the oceans according to their area from least to greatest. So what we want to do is we want to look at the exponents for the most part. So we want to go through, and I'm going to zoom in on my other screen here because that's a little blurry. Apologize. I thought one of those was a 5 already. So this is a 6, 7, 7, 7, and 6 again. So again, I'll have to come up with another method on copying these so they don't come up so blurry for me. But what we want to do is just compare those really quick. So the 7, that means 7 digits, that's going to be bigger than the 6. So we want to look at these 7s first and see which one's bigger. So now that we know these are the biggest ones, we can look at the number in the front. So we have 6, we have 2.65, 2.95. Well, 6 is the biggest. So that's going to be our biggest ocean. Remember, we're going from least to greatest, so I'm kind of talking about that backwards. But Pacific would be our very last one. That's the biggest one here. So you could also do this in the same way, making sure you're going from least to greatest. For whatever reason, I was thinking of greatest to least. So the next one would be 2.96 because that's bigger than 2.65. So the next one would be Atlantic. Atlantic. The next one here would be Indian. All right, and I'm going backwards from greatest to least. All right, so now we have 6 and 6. So we know they have the same number of digits. Now we just need to look at this number in the front here. 5.43 or 7.85. Well, 7's bigger than 5, so it's going to be Southern. And then the smallest is going to be the Arctic. Arctic. All right, so that's just a way of looking at it. So you look at the exponent first. So the bigger the exponent in this case, the bigger the ocean. If they were negative, then the bigger the exponent, the smaller they actually are. Because remember, that means that it's moving even farther to the left. It's getting smaller and smaller every time we make a bigger negative exponent. But if it's a positive exponent, the bigger that gets, the bigger the number gets. Okay? I do believe that will be the end of section 6 here. Let me move to the next page. Yep, that is the end of section 6. So I will see you in section 7.